Let's go live here. All right, so we're now recording. So I just want to say welcome everyone. Thanks for joining us. This is officially the NR 493 seminar class. It's the seminar on GIS and remote sensing applications, GIS applications for natural resources, very long name. And it's a joint event with the Geospatial Centroid, which is the GIS lab on the CSU campus. So we do these seminars, we're doing them like twice a month. And today, we are fortunate to have Boyd Lebeda come speak about how GIS was used on the Cameron Peak fire. And for those of you who are actually in the class, don't forget next week we don't have a live class. You're just working on your model builder assignment. And I will be around by email here and there, but I might be taking a day off that day. So for those of you in the class, we will meet again live on March 22nd. So with that, I will pass it over to Boyd. And you can introduce yourself and share your screen and kick it off.
Yeah, very good. You guys, you hear me well enough? Nod? Yeah, great. Okay, good deal. Yeah. Well, thanks for letting me be part of the seminar, and thanks, Beth, for reaching out. I think you might have seen me on one of the Facebook Live community meetings during the Cameron Peak. Is that how you found the contact?
Yeah, so I mean, I knew what you did just because I know Sherry, but
yeah.
Yes, that's what sparked me to contact you about this topic specifically.
Okay, cool. Well, I'm not a GIS professional. I'm a huge fan and do a little bit of work with it myself, but I access and utilize a lot of GIS work that others have done and do and will be doing. So big fan. Pretty cool stuff. So anyways, just a little backdrop. Day job wise, right now I work for Colorado Department of Public Health and Environment. I am in the smoke management program. So in Colorado, as in most states, to meet the requirements of the Clean Air Act, every state's got to have a state implementation plan for all kinds of emissions, including smoke from prescribed fire. So entities that are going to be doing prescribed fire in Colorado pull a permit and to implement their prescribed burn, and I'm the field liaison for that position. So it's been fun learning kind of another dimension of atmospheric science that I never really had before, and just making the tie into wildfires and all the forestry and fuels work I've done over my career. So it's been pretty cool. I've been doing that about a year and a half. So also the connection to this talk is related to the incident management team that I serve on. So that works on the wildfires, and that's how I came to work on the Cameron Peak. And so I serve as a fire behavior analyst on one of the Rocky Mountain area type 2 teams. Fascinating job. Just never get to the bottom of an answer, but it's just a fascinating process. And I'll go through some of that through the talk here. I do have a PowerPoint slide, so I apologize in advance for making you look through another PowerPoint, but it's kind of hard to not share awesome fire pictures when you're a fire person, right? So here we go. Give me a nod or something if you can see my screen. Can you see us? Okay, awesome. So Cameron Peak fire, of course, just a really epic fire behavior, ecological phenomenon, community impacting event here. Just really big deal. And I've worked on a lot of large wildfires like this in my career, but with the exception of High Park, I always went somewhere else and worked on the fire and then came home and quit thinking about it. And wow, when it's in your place and in your community, you just feel the impacts of it, both ecologically and socially, just that much more. It just really, it was just really impactful about how aggressive this fire was, especially, and just how it moved. And what it did. So anyways, this is just a really cool picture. You'll see it again later in there. But so let me tell you, a little bit about myself here. So I am a CSU alumni. I got a bachelor's in forest management in 1987. That time was the dawn of the PC. So it's part of how I met my wife, because she knew how to do PC and I didn't, and that was fun. But the first time I ever saw a GIS map was when I was working as a forester for the Bureau of Indian Affairs at Northern Pueblos Agency, and the soils guys were the ones that were the GIS operators, made some maps for me for a forest management plan I was working on at Picaris Pueblo, and I was just enthralled by even how it printed, how it would draw some lines over here, and then the plotter would move over here and draw some other lines. Even that aspect of it, I was just really fascinated by. So obviously at that point, not even thinking about any analysis, I just thought it was awesome that it could make tidy maps rapidly. So anyways, I had a long career with Colorado State Forest Service after that. I was a district forester for 20 years at Alamosa District, and then here at Fort Collins. And the downside of that in terms of GIS was I always had somebody who could do it for me. I always had a forester who was younger and had it in school and had more opportunity to practice and use it. And so I just never really got forced to dive in and learn how to do it. So getting a little bit of that now. I told you that I'm working in the CDPHE and this field liaison job. So I'm doing little bits of stuff, trying to, populate maps with our permits, and then use tools like Survey 123 and Collector to populate information I collect when I go to various burns on there. So also told you I was doing the fire behavior analyst. Last point is I'm not very good at reading directions, so I just like to try stuff and see how it works, and that doesn't serve me the best all the time. But anyways, more not a very auditory type learner on that. So anyways, to the High Park fire, really, or I'm sorry, Cameron Peak. So this is an infographic made by one of the incident management teams, and it take a little time to study it and see about the duration and the events that occurred during and through this fire. So August 13th, the fire started, real high elevation west of Chambers Lake, which is Cameron Peak up there, real high elevation. But we had come through a summer, well, no, thinking back to all of 2020 in terms of moisture, we had a pretty average-ish winter last year in terms of snow and even spring precipitation. And then in early summer, we got warm, and then the normal monsoonal wet thunderstorm pattern that we normally get in July and August just did not happen. And it got hot. So that just immediately started to bake the fuels and dry everything out, and it did it really fast. So all of our indices that we use to measure dryness and availability of fuels really just climbed, and all of a sudden it was game on in terms of a fire season. And we got to see that with Cameron Peak. Cameron Peak just took off like that. So this is the sequence of all the different, in the blue blocks are the incident management teams that worked on it. I was on Rocky Mountain Team Black. And so we were there over the Labor Day event. I remember that so vividly now, but you may not. If you will recall, Cameron Peak Fire was just kind of still in the upper part of the Poudre at that time. It had crossed the highway, burned up on Green Ridge, kind of moved down towards the park, but still in the wilderness for the most part and up high. And then if you recall that there was a pretty, really profound weather event, a great big low that moved across the North America right preceding and then after Labor Day. And what that did to Cameron Peak Fire was give us just pounding, brutal wind. Oh man, Saturday, Sunday, Monday of Labor Day. And that's what drove that fire. It grew, as you can see on the graphic, 78,000 acres in that episode. And then it snowed 8 to 12 inches. You remember that, right? In September, early September. So not only here though, but the California fires also as well experienced really fantastic winds that pushed those fires great extent, even farther extent and bigger acreage than Cameron Peak. So this really, really big, a bit of an anomalous weather event for late summer like that. So fantastic kind of a growth when you can look at the ecological side of fire and what it did. But yet that time of year is still warm, still pretty dry. Actually, the fall is a very dry time of year in the Northern Front Range. And we didn't expect even a snow of a foot would put the fire out. It's easy to conclude that, but obviously that did not happen. So there was periods of time that it resumed growth when the Southwest team was here. And then the other great big event was when the other Rocky Mountain team, the Type 1 team, came on October 12th. That was when it made its fantastic run from the Pingree Road up by where the High Park fire is and near Mountain Campus, and pushed it all the way down to Buckhorn Canyon, the lower Buckhorn, in a single burn period. Another just like wow, we're not used to seeing that. And then it snowed again later. So anyways, just fantastic things we had not seen before. So although our perspective of wildfire on the planet is comparatively short, you know, we've got a few decades, maybe a century of observing fire and seeing what it does, and yet we're on a bigger time scale than that. So just really well done graphic and whew. So obviously good pictures. The one on the left is that from Joe Wright Reservoir on the dam looking towards the north and east. So what we would be looking at is that one of those days right immediately prior to, this was probably the Friday prior to Labor Day. So it was up on the Elephant Butte or Sleeping Elephant over there. And we were knowing it was going to get exposed to the wind and take off, but this was prior to doing that. And then the picture on the right is just later that afternoon. This was from up by the state line, just south of Woods Landing, Wyoming. And you can see the pyrocumulus build that high. And that's when a pyrocumulus is when there's enough heat in the smoke plume that it gets pushed up through the atmosphere where it can encounter some precipitation or some moisture and then form a cloud, a thunderhead cloud above the smoke column. And that's why that's that puffy white up there. So also striking about these pictures is when you look at the landscape and think of relative to the atmosphere, how thin of a layer the fuels are, even though we might be looking at a forest canopy that's 60 or 70 feet tall, something like that, maybe. It's just producing a fantastic amount of smoke and emissions production in there. So anyways, just kind of the fascinating, all parts of wildfire that we're looking at here. We get data. So one of the things that we start to get data and use that to make analyses on is infrared imagery. There's a couple of different platforms that we get good infrared data. One of them is from the NIROPS. I'll describe that later, but a nightly flight that measures heat. And then the state of Colorado has a multi-mission aircraft that also can fly daytime and other missions, and they can produce GIS map products. And they do shape files, of course, but one of the really useful things that they can pump out and everybody can get their hands on and use pretty fast is Google Earth KMZ files. And this is just how that analyst that's in the aircraft is collecting the points, and they draw polygons around those in this. So in this case, we're looking at the dots would just be kind of isolated heat. The red line is the analyst drew a line around where the collection of heat was, kind of the outer extent of it. We'd call that the fire perimeter. And then the yellow polygons, yellow shaded, or would be there's enough collection of heat signatures that they're not going to identify each one. They'll just as a zone with a certain density of them. And then the intense heat would be the red ones, which I don't see on this image, but just a more intense heat. So those are telling for the operations people, deciding where there's potential for it to get up and move, or where it might have some action, or where they might have more resistance to actions that they're going to do. So this image was taken August 27th, while it was still up in some pretty high country. But just Google Earth is a really a useful tool. We look at that a lot. And also, remarkably, when there's even just those individual dots that are outside of the line, they may or may not be a spot fire, probably are. And when the fire actually made its big run when crossed over Crown Point and ran down to the Pingree Road on Labor Day weekend, that run started from a really small collection of those individual dots. It was not a great big heat source that was able to make a push. It was all dry fuels and generated its own heat and got picked up by the wind and pushed across there. So, wow, it's fascinating. So one of the map products that are the GIS specialists that work on these incident management teams do, my favorite map is the progression map. Tells the story of the fire. Of course, there's a tiny font in the legend just to get that many days on there. So when we think about wildfire and how it occurs on the landscape, we're kind of used to a paradigm where it gets started, it makes a run, the run ends, we get around it, contained, and it's a few days. Well, we're not seeing fires like that anymore. The mountain pine beetle affected fuels are a factor, just the scale of fire, the climate that's allowing fires to behave a little differently. We're having much longer duration events, and they have episodes, of course, and pulsing that they make that movement on, but long duration events, that's probably the future of how we're going to see wildfire occur in the Rocky Mountains anyways. So anyways, real interesting color shading. You can see the bigger polygons in the green were the days of the Labor Day, and then that orange one was that big run in October, took it down to Masonville and nearly to Horsetooth Reservoir with the spot fire over into Buckskin Heights there in Redstone Canyon. So anyways, very interesting. All of these perimeters would have been acquired through one of the infrared sources. So not very much of this would have been collected by somebody with a GPS or any of that kind of stuff. This was just because of the scale that we're looking at, it's collected that way. Also, it's aircraft based, the way that's collected, some kind of airplane or helicopter for that matter. The satellite data that we can access to register heat can help us tell some information about intensities, but location, with how fine of a locations we need for use of satellites that aren't currently not providing, or maybe where we're looking, but it can give us some indication and signature of heat, but the location, just because of the triangulation off of that, has been a little tougher to make that usable for us. Here's a product that we use. It's the Wildland Fire Decision Support System, WFDS, and you can see the Cameron Peak fire kind of on the right side of that, but I pulled this up for kind of zoomed out a little to show the activity not only in the past decade or two, but also what happened in 2020. So that big red one up on the top is the Mullen fire. That was a fire that occurred on the Medicine Bow National Forest, kind of on the southern snowy range up there, as well as the East Troublesome. You know, for a while, we were worried about the Cameron Peak fire being able to squirt around and affect Estes Park. And there was lots of talk about how to evacuate Estes Park and what kind of things we need to do to be ready for that. And that all proved to be valuable, but not because of the Cameron Peak fire. It was because of the East Troublesome that started over just north of Kremling. And again, similar situation. It started later, so it didn't get to experience the Labor Day, but it experienced those later wind events, and it pushed it, of course, all the way across that range, Willow Creek, Grand Lake, and spotted over the Continental Divide and got established above Estes Park and made a run down towards town there. So really remarkable kind of stuff. Also, you can see the Cameron Peak was affected by a couple of other previous fires. The High Park is the yellow blob on its east. So that was a asset, I guess you could say, that it did check up the fire's movement because it had burned recently and there'd been not enough regrowth of vegetation to really carry fire well. And then the green one on the bottom of it, the southeast corner of Cameron Peak, is the Bobcat fire, burned in 2000 down in the lower Big Thompson there. So anyways, to me, it's just fascinating how these, what's happening on the time on our watch, so to speak. We're seeing really a significant forest change. We're seeing the ecology respond to what the forest condition is, or fuels condition, and just doing what it's going to do. So really interesting time to be in and be looking at wildfires as a issue. All right, kind of a busy slide. Let me talk this over, but man, maps and the analysis we get from maps are just an indispensable part of the vernacular for how we manage wildfire. So there's two columns I'm going to be talking about in this slide. The one on the left is about at the incident and the GIS staff that's doing analysis and producing products at the incident. The one on the right is the analysis, more heavier analysis side of things that's done both prior and during and even after, design of how we're doing analysis and looking at those. So on the left, we've got in the incident management organization, a GIS shop that works in the planning section. That's a regularly carried position. There's just lots of value and expectation to produce good map products that we need to do almost every function within the incident management team. So there's operational maps that that division supervisors and engine bosses and the hotshot crews and all those guys are looking at. Transportation maps, the logistics people need to deliver whatever fuel and pumps and whatever out to a certain place. They've got to know how to get there and where to get there. Of course, there's huge demand for public information maps. And every briefing, every meeting has got a map. And a lot of them are printed, but a lot of them are just QR code. You can download, a Venza type, for navigating those things. So every time there's a change, though, they got to make a new map. So every night, basically, the infrared is flown. The NIROPS, the National Infrared Operations, flies and gets a new perimeter. And if the fire didn't move the day before, then the GIS people won't have to make that adjustment on the next iteration of the maps. But if the fire did a movement, they'll have to generate a new map. Or if a division, the operations created a new division, or if there's new drop points or things. So it's a pretty fast-paced cycle. It's exciting. And we just need those. So those people work some odd hours because that flight is done at night and the data gets posted at anywhere from midnight to 5 o'clock in the morning. And somebody's there watching to see when it gets posted, and they start busting out the new set of maps that are going to get used the next day. So interesting. I mentioned the satellite platforms. give us some pretty good heat signature, but location is a little tougher. So on the right side is part of the analysis. When we're trying to, especially when we get to the fire behavior stuff, we're going to be trying hard to do spatial analysis of what the fire is going to do, what we think it's going to do. And so, of course, you may have been through a fire class, but the fire environment is basically made up of fuels, topography, and weather. And so we can incorporate all those things into spatial tools. We are using a mathematical model for fire spread, the Rothermel model, which has been around a really long time. And it does have some limitations, but nobody has really come up with anything better yet. We're still working with that, but it's just such a difficult, fire combustion alone is a difficult modeling exercise, but then adding all the dynamics of weather, fuels, topography, seasonality, climate change, it's a really difficult problem. But we do use it, and we do our best with it, and we do lots of calibration to help refine it to get to calibrate it to what we're actually seeing on the ground. So obviously we're using a digital elevation model for the topography. Fuels layer, you may have looked at Landfire. That's kind of the national wall-to-wall data source of fuels data. It's really a comprehensive, good set, 30-meter pixel based fuels data. So while that's good on one hand, and it's good to have because it's a continuous carpet of data, man, to make an assumption that a given relatively tiny set of pixels that are adjacent to each other, that it's going to be accurate to what the fuels actually is on the ground, you know, it might not be that way. So we have to query our landscape file and make sure it represents what is on there. Of course, weather inputs, our National Weather Service does a really nice job, and there's a bunch of nice products on that, but they're on a scale maybe as small as a kilometer in terms of its scaling. So we can overlay that, of course, over fuels and DEM data, but yet there's also user inputs. So like I mentioned, the lack of the monsoon. So the fuels just will describe the characteristics in the model of the fuels. We still have to give inputs about how dry it is, how long it's been since precipitation, you know, just how available it is to burn. So there's other user inputs that we do. In addition, there's scales that are really, really difficult to model. So even within a 30-meter pixel, if you think of a 30-meter pixel of forested area, there's still lots of variety within that. You know, spruce trees, fir trees have branches all the way to the ground, or they don't, or there's a bunch of woody fuels on the surface, or there's not. The satellite imagery that is used to derive most of that landscape file can't see through a canopy. So if you're looking at a ponderosa pine forest, you can't necessarily tell that if it's a gamble oak understory, or if it's pine needles, or if it's grassy, unless it's an open canopy. So there's lots of finer scale stuff that are a big deal on how a fire burns through a 30-meter pixel. Then we really have firsthand direct knowledge of without going to look at it. So I'm building up to saying why I can be wrong, right? Because on one hand, it's just so obvious, you know, it's windy, it's dry, it's hot. Yeah, the fire's going to get up and move. But when, what day, where, and why are all legit questions that we're trying to answer with this modeling exercise. So anyways, fascinating stuff. Also, knowing what question to answer is important on it, what tool we would choose to use to do an analysis. So if we just want to know how long the flame lengths are and how fast it's going to move in a certain place, we'd have a tool. If we'd want to know, what are the odds of it reaching Estes Park, that'll be a slightly different tool. When is it going to reach the Pingree Road? Those kind of questions. So before we really start diving in and doing analysis, we need to kind of think about or know what question we're trying to answer there. So here's examples of those different products we do in that Wildfire Decision Support System, WFDS. So these were all models that were built independently and then placed into this. So all of these, I'm going to start in the upper right one with the fire behavior on that 30-meter pixel at a point in time. So the upper right you can see is a highly pixelated one. And what that is a short-term or a basic fire behavior analysis. And that would just say for each of those 30-meter pixels on the landscape, it gets assigned a fuel model. That's what the landscape file is. A digital elevation model, so a slope, which is going to include which aspect it's facing, how many degrees slope, and then we'll overlay the weather on that pixel. So we will pick a temperature, a wind speed, a relative humidity, and that will all derive a fuel moisture. And then the Rothermer model says, based on those inputs, it is this kind of fire intensity. So that it's color ramped, of course, to reflect that. So the darker the green, the more modest the fire beam intensity, and the more yellowish, orangish, reddish, we're looking at more potential intensity based on those inputs we gave. So that's how it gets derived. On the upper left, now in each of those pixels, we are looking at a place where we're looking at what the spread is. So each pixel might have a different fuel model, and they are going to burn at different speeds based on the characteristics of that fuel model and the inputs like wind. And what we're seeing in the upper left is a flow path example. So the red line that looked like a venation of that is the fastest combination of the direction the fire is going to move over that period of time. So that one would have been probably a couple of days worth of projection from that fire perimeter. So the red line is the fire perimeter at the time that analysis was chosen. The gray is in the middle, that's already burned. We're not going to try to model for that anymore. We're just concerned about where it's going to try to get to next. The yellowish ramping is the nearer time, probably some kind of a time stamp that we would think it would get to there. And the edge of the blue is where we think it would be at the end of that projection period. The red lines are going to be where we think the head of the fire, frankly, will be. That's the minimum travel time flow path. The lower left is another pixelated one, but this is answering more similar to the previous question. Where is it going to be after so many hours? And these are 1, 2, 3. You see the colors, yellow, brown, and blue. Those are 3 days, basically, those 3 burn periods. Where do we think it's going to be given the expected weather over the next 3 days, where it's going to travel? And then, of course, around to the lower right is a probability map. So based on a 14-day analysis, and the red line being hot, there's no suppression action assumed. It's not like we're assuming firefighters are putting out an edge of it. This would be the probability of those pixels burning in the next 14-day period. And of course, red will be the highest probability, and then brown, yellow, green, purples getting to lower probability. So this helps us figure out, at least for one snapshot in time, to say what we think is going to happen over these next days. And then even when we get to those lower probabilities, down to the green and purples, we saw that a lot in 2020, where it reached the rare event, which is the troubling thing for an analyst like me, is that it usually doesn't happen, right? I'm trying to call the rare event, and that's difficult to tell, like the forest supervisor or the district ranger, that yeah, the red, it's going to get the red, but is it getting the purple? Well, it usually doesn't, right? There's only a 5% or less chance that it's going to get to the purple, but this is 2020 and we've seen fires exceed what we thought they were going to do. So anyways, it's a really fascinating problem, kind of squishy, kind of hard to do, but a really interesting challenge to try to figure this out. So anyways, I want to leave a little time for questions if there's any. I just wanted to also mention some of the air quality related stuff to wildfires. Two images. On the right is the Purple Air Network. That you might be familiar with that. It's just basically a citizen science version of low-cost air sensors that you can place at your own house or school or wherever. And it just has its own tiny little onboard Wi-Fi. It hooks up to the Wi-Fi of a building and collects particulate matter data and pumps it out to their website. And it's pretty cool. It converts it to a bunch of different things. In this case, it's the EPA PM 2.5 air quality index. The colors are probably the most important part of that. You know, green's good, yellow isn't so good, red's not really good at all. So that's a good tool. Those also get populated to that map on the left, or that image on the left. The fire.airnow.gov is where a bunch of other sensors get populated as well. So these purple airs that get QC'd basically get populated on that map along with the regulatory sensors. So like CDPHE has sensors across the state that are meant for regulatory purposes. The US Forest Service has a cache of sensors that they can deploy per incident, you know, for like a big prescribed fire or a big wildfire outbreak, and they want to know data from some places that they don't have sensors at. And those get populated on the fire.airnow.gov, which is a relatively new thing. Just being a citizen, it's nice to be able to look at that. And especially for like living in Fort Collins this year, when to not run, or when to run on the treadmill and when to go run outside. Because if you go run outside when the air is that bad, you are not helping yourself in that situation. So anyways, just interesting part of that. Also spatial application. We see a lot of that. You know, people resonate with that when you can show a map, and especially a map that's got something valid and is accurate and is up to date. It's powerful thing. So anyways, like I was telling you, I was kind of a neophyte GIS user. This is a map I made of our permit locations for 2020, and this is the map I use for the Survey 123 populating data about different burns that I go to, and I also place the perimeters of the some of the big fires in Colorado over this last year on there. So anyways, pretty cool stuff, pretty fun. I'll just stop talking there, and I'd be happy to take any questions if anybody's got something. I'll stop sharing.
Thank you so much, Boyd. That was great. Yeah, we have officially 10 minutes left in the class, but if we go longer and people want to stay, that's fine. So if you have questions, you can either put them in the chat or just unmute and talk. Are there any questions?
Hi, I have a question about in terms of the accuracy for starting the source of the Cameron Peak fire. How has any analysis been conducted on not only finding what was the source of the fire, but where it specifically started and what the overall accuracy of that is in your experience?
Well, I have not heard an official statement about what caused the fire to start, but the location of it has got a pretty good, from the initial reports and the initial photography and initial responders, the location is pretty good. If that there is a fire investigation science, and it's good and it works, and works better in some fuel types than others, but there's ways to determine which direction a fire was spreading at a given location. So you can kind of start to narrow down the actual ignition point based on how, say, blades of grass burn, which way they fall on a really slow moving fire. You can tell which direction a fire was spreading from that. So long answer, but as far as the analysis part, the only real good data point I can think of that we would have would be lightning, because there is pretty good lightning detection data spatially. However, there wasn't any lightning. That was probably not a lightning caused fire. It was probably a human caused fire. And that's another reason that makes that source location detection difficult, unless somebody just said that was me. And here it was.
Yeah, thank you. Thank you so much.
Hey, Boyd, I've left some things in the chat. If you can hit your ... you'll see some.
Sorry. Yeah.
And Sophia had a question too, so she can be next.
Hi, Boyd. Thanks. That was interesting. Can you hear me?
Yes, I can.
Okay, great. So I was curious, when you run those models and then the actual fire does what it's going to do you do some sort of comparison to what you thought was going to happen and then what happened? And then the follow on is then once you see that, can you feed any of that output back into models to better inform your future model?
Yeah, absolutely. That's the entire exercise. So what really, I guess, troubles me is that it takes us a whole bunch of calibrations to match what really happens. So if we see like those early days in August, that the fire was on the move, we have to, turn all the knobs and stuff on live fuel moistures and, all these things to get some calibration runs to match what happened looking back. But then once we have that, then we feel good or good enough about those. Then we start using those inputs for projections into the future, also looking at the weather that we're expecting. So what we can calibrate stuff like the fuels in there, right? We can say it's this dry, turn this knob, click this one up, click, we can do those things to kind of calibrate the fuels and then overlay the expected weather. And then make projections based on that. So yeah, that's the intriguing challenge of doing the modeling exercise.
Yeah, and how do you find, like, what part of the time are you right? Like, can you just say anecdotally, like how does it perform generally?
I think so. The early days, so maybe like say for an emerging incident, I would say there's probably, a couple of days at least of running it and trying to figure out what is going on. But then once we get, the fuels kind of dialed, what we think they're going to do, we are getting a good read on weather. I think we've got pretty good confidence in what the outputs are initially. So our first products, it's just like, your first test, right, Beth? Your first test, you might just take a digger on and then you start figuring out what Beth wants and then you start getting it, right? So
That's
it's kinda
exactly
like
right.
that.
How did you know? All of my students are agreeing right now.
It just takes a while to figure out what she's looking for, right? Yeah, so fire behavior is a little bit like that, just because so that really surprised me when I first got into it. I thought, man, we've got all this awesome, we've got light, we've got places where we got LiDAR data on fuels. We've got this great digital elevation model. We've got good weather forecasting. I was like kind of taken aback that we don't have a really good out of the box projection, but we've got a okay one, and we're getting better at the calibration exercise of that.
Modeling is always the swag on the beginning of a fire.
Oh my gosh, and the extent that it goes to. So like the day that it ran from Sleeping Elephant up to Crown Point, and then it ran down to Pingree Road, we knew it was going to make a big move. There was really not any mistake in recognizing that. Where it is going to stop, I just, that part you can give some wags about, but to tell the sheriff that, yeah, it's going to stop before it gets to the Pingree Road, because if the wind slacks off at 5 o'clock in the afternoon today, then it might. If the wind keeps blowing till 8 o'clock tonight or 9 o'clock tonight, then no, it's going to keep moving it. So you're kind of at the mercy of the dynamic nature of those things, especially the weather and how the topography interacts with it. That's another very interesting thing. So like Poudre Canyon, of course, is a narrow, pretty deep canyon in places, and it really mixes out the wind. That's why it probably didn't really get up and move big in August, because it's just such a complex topography and the wind kept getting kind of mixed out. But man, once it got up onto some high ground and got exposed to the wind, like on Bald Mountain on the Red Feather Lake side, and got up high ground at Crown Point and Signal Mountain and got pushed, then it was all just exposed to the wind, and there wasn't that topographic influence. And wind was so strong that it pushed fire downhill in elevation a long ways, right? Normally we think heat rises, warms up and dries out fuels above it on the hill, it's going to want to move uphill. That's true. But if it's already dry and the wind is blowing 70 miles an hour, it even can and will push it down the hill. So like from Signal Mountain, Mountain Campus area down to Buckhorn, you're probably losing, 3,000 feet in elevation, and it pushed it down there in a burn period. So fascinating problem. We'd never, if I would have used that in a scenario for like a fire training, people would be like, what? What had happened? Well, I haven't even had time to read any of the chat questions.
Yeah, there's one in the chat, but Andrea has had her hand up. So
I'm
why don't
sorry.
you hop in
Yeah.
there, Andrea?
Okay.
Great. Thanks, Boyd, for sharing with us today. One quick comment and then a question. I just found it interesting how you were talking about, this year, the purple zones, the low probability burn zones were going up. And it just reminds me of what we're seeing with floodplains more and more, where there's floods into the 100, 500-year floodplains. But my question was, how much does the beetle kill zones, sudden aspen death zones play into your all's fuels calculations?
Yeah, great question. So to your first point, yeah, that is true. And that's happening a lot. I think part of it is our historical knowledge time span is short. Like I said, we don't know how fire burned here in the Little Ice Age and the medieval warming period. And, we only have this century of collective data. So we don't have a very good picture of the overall, nor do we really have a good read on how climate change is going to affect how those things will happen in the future. So what was your second question again?
It was related to fuels, and you had mentioned relying heavily on land fire, but also how much some of the different beetle kill zones, sudden aspen death zones.
So you guys, you're aware of the mountain pine beetle epidemic that occurred in the Central Rockies. Most of that activity in Colorado happened in northern Colorado, and it happened from kind of a slowly developing thing from the late 90s to about 2009, and it got worse than around 2006, 7, 8 in there for northern Colorado. So we expected there to be this phase of where the trees are still standing and they're holding all their needles and the needles are all red. Should be a really flammable condition, right? And then the needles come off and we have a period of time where trees are still standing. There's no needles on them. We probably don't have the great crown fire capability because there's not needles on the trees. Then lodgepole pine stands, for 8, 10 years or so before the root system rots off and the trees fall. And then we've got lots of fuel on the surface. We've got lots more wind exposure. That's one of the things about lodgepole pine. It grows in such a dense stand that it actually protects the surface from wind and correspondingly fire spread because of that. So really difficult problem to solve. In British Columbia, just when they had their mountain pine beetle epidemic was kind of before ours, they had really vast areas at a time compared to us. And they did have notable increased fire behavior and crown fire activity with the red needle phase. We didn't have that because I think it was too slow moving and we didn't have that much all red needle at one time. Our forests were all green, red needle stage, and then ones that were already killed and dropped. So what's happened recently though now, so we didn't have a really good manifestation of fire in mountain pine beetle. And as far as modeling, we're still, and to a degree still are using the regular timber litter and timber understory series of models for that. But now that we're all these 10 years and beyond, we're seeing lots of the lodgepole pine fall. And depending on how much mortality occurred in those places, we're seeing more of the canopy down on the ground. So like Middle Park, North Park, Summit County, or not Summit County, but Grand County, there was a higher percentage of trees killed than there was on this side of the Continental Divide. Don't exactly know why, but that's what happened. So over there, it's like open. It's more open with lots of down logs and lots of regen of lodgepole coming up through it. That was what the East Troublesome Fire moved through. Got exposed to great big wind, lots of huge amounts of dead fuel. So mountain pine beetle changed the fuel component from a living tree, which still can burn, but probably not all of it because it's got moisture in it, to that same loading of all dead fuel, and all, when it's dry, is all available to it. So a much higher intensity and availability to burn. So this is really turning into a ramble. But anyways, fascinating problem and difficult modeling. So land fire is not necessarily catching that up. So this is one of our calibration issues. So we start the first days of the Cameron Peak fire, and land fire says it's whatever, TU5, timber understory 5, and we run that, and and then we see the wind get on it and move it, and we have to start looking at different models, just sheerly, not even necessarily what their descriptor is, but how they mimic mathematically what the fire's action is actually doing. So we might be picking a chaparral, like a model we'd use for Southern California chaparral. Just if it mimics what the movement of the fire is and the intensity, we need to use it because that's the one that's working in this case. So the beetle kill is a difficult problem, and it's got to basically be solved per incident, per fire, because it's just not uniform. The forest is just not uniform on how beetle moved through there, and the resulting forest we're looking at now in fuels matrix right now. So yeah, man, we need somebody to really figure that out.
So can you speak to the use of the forest health data that's out there that's being flown on a regular basis to help that?
The aerial survey?
Yep.
Yeah, so yeah, the aerial survey is good. And we use that a lot, like on the Beaver Creek fire. I don't know if you remember that one, 2016 up in North Park. It was kind of the first big lodgepole beetle kill fire we had. So the aerial survey is helpful just to give us an extent and where those occurred and where lodgepole is for that matter, and where it transitions to more other species. So one of the issues with using it and really having it drill down for us is doesn't always tell us. Well, they don't keep flying it for one thing, and we don't. So the mortality rate is a little difficult to derive, and even when we do derive it, like I said, there's just enough variety in these stands and how they get affected that it takes time for land fire to get caught up with that situation. And then when we do an edit to the land fire data to represent the beetle kill and the trees falling, it has changed again, because trees starting to grow in. It might have turned to aspen. Yeah, no, I really like that we've got that and we're looking at that. But it's been a difficult thing. One thing that has informed land fire pretty well is the forest inventory analysis data. The FIA is I don't know if you're familiar with that, but a pretty involved plot.
That was what I was referencing. Yeah.
Oh, were you? I thought you were talking about aerial survey.
Well, that both go kind of hand in hand in their whole program, right?
Yeah, aerial survey is coarser, but FIA has got good data and it does get populated into land fire. Land fire is on approximately a 2-year cycle of revision, but it's always on a 2-year lag for that. So what we have now is 2016 land fire, which is not bad for like a stand that's not killed, right? For a conifer forest, 4 years is not that much of a change unless it's coming apart because it was affected by mountain pine beetle.
And can you briefly talk about the use of the UASDs now on fires as a fire position, and the use of UAS for hotspot analysis, as well as are you requesting any UAS flights to get you data for your inputs at all, or is it more operational where the hotspots are?
Yeah, that's more operational, but yeah, the UAS is a really good tool and it's emerging. I think as we get more familiar with it, so for like a hotshot crew or a division that's going to be working in an area that needs scouted, the imagery is really, really helpful to them to be able to do that, as well as heat sensors that they can be looking at in there. They can also deliver aerial ignition. This is a really promising future for that. So places that we need to burn out, put fire on the ground, and it's just too nasty to ask people to go in there, it's too dangerous, we can do that with a UAS. I think those kind of things are really promising for the future. Man, we just need the data intel that we can gather with that, just with the sensor capability that they're going to have, is going to help us. So like I'm thinking LiDAR, if we can really build better pictures of the fuels, I think that will help the fuel modeling that goes into the bigger fire behavior model as well.
And the other side of it is also now the recovery side of them doing seedling, delivery.
Yeah, great point. Yeah, and because one of the lessons from the High Park was that 87,000 acre fire occurred, but really tiny percentages of that acreage were a really big problem for our water quality and sedimentation and sediment movement, like in Poudre Canyon, right? The places that it washed down and damaged the road, damaged the water infrastructure, were really tiny on that. So those are the kind of things that if we can have a more refined tool to collect data, I think that's got a chance to help us make predictions about what some of the post-fire effects are going to be.
Do you want to just talk on how we then use all these products with the bear piece to help for the other students that are kind of interested in the other side of fire?
Yeah, so the burned area, wait, what does it stand for? Burned
Emergency
emergency response. Yeah, so post-fire, we're going to get erosion, and based on what forest type, what time of year. Another interesting contrast between High Park and Cameron Peak is I think we're going to get kind of a break on post-fire erosion from Cameron Peak because we didn't get an immediate summer thunderstorm to move sediment on it. That's what happened on High Park, and that's what moved a lot of sediment and ash down into the river corridor. Cameron Peak burned some similar country, but got followed by snow, which is generally a much better precipitation to get on a burned area in terms of flooding. We could still get that because, right, there's not a lot of vegetation regrowing on that. So data like that and how hot it burned, how much soil's exposed, how much hydrophobicity is occurring on that place are all things that feed into this burned area review, and that we can then make plans about where we can expect problems to happen, where some mitigation activities, maybe seeding, other things might be beneficial to help minimize some of those post-fire impacts. Wow.
Awesome, thanks. And I guess that other key is what most people might not know is how hot the fire gets really determines that hydrophobicness of the soils and how it now acts like a parking lot in the preceding.
Yeah, so hydrophobicity, of course, is the waxes in the vegetation becoming melted, and then as the fire cools, they seal it and make kind of a crust. And then once the crust breaks through because of rain, like a summer thunderstorm, it breaks through and really starts to erode it and move sediment. One nice thing about a late season fire like Cameron Peak and having snow on it is that it will have a freeze thaw cycle happen to it. And that tends to break up hydrophobicity. So I guess that we can look forward to potentially that benefit of the time of year from the Cameron Peak.
Awesome. Thank you so much. This was really good. There are a couple more things in the chat. People might want to go. It's already 5 o'clock, but Boyd, if you do have a minute, there were a couple of comments from Michael Peters, who's still here. If you want to shout those out, Michael, about one is talking about drones and the other one was further up about implementing potential operational delineations on a bigger scale.
Oh, they were just comments as he was talking. If he wants to read them later, that's fine.
Oh, okay. Okay, I wasn't sure. Yeah, they're not questions. And then there was a question that just came in. Do big fires, especially the Cameron Peak fire, change the tree and shrub populations in the burn areas? How vastly does it affect the populations of other living species in the areas?
So, yeah, Cameron Peak fire is native forest, all forest types, and even a place I believe that have had fire occur on them before. And so we in some of the ecosystems like the lodgepole pine, this is right in its wheelhouse for regeneration. This is just what lodgepole does. When something happens in a lodgepole forest, regenerate it, it usually happens in a pretty big way. And we got to see it with mountain pine beetle and then the fires. And I do expect pretty good natural regeneration in lodgepole pine. I really wouldn't expect much of a type conversion there based on what we've seen. Of course, the time scale is pretty long. We'll probably see more aspen colonize areas that it was not, or it had been encroached on. You know, aspen was probably bigger at one time, and conifers have encroached into it over time without disturbances happening. And now this disturbance has happened. I expect aspen to emerge maybe in places that it was dormant and possibly colonize out areas where it exists now. Spruce fir, of course, is not a fire resilient species. They get burned up, and those will be ecosystems that will likely naturally regenerate towards those forest types, but it's long. That will be a slow progression because just because of the growing season is short and the growth is slow, and other plants that grow faster will colonize that first. And also, fortunately, don't necessarily, I'm not aware at least of any troubling invasives in those forest types. We do at lower elevations, but that's a good thing in my mind for these higher elevation forests. Although there could be something out there that I don't know about, or that we all collectively don't know about yet.
Did you create an operations dashboard for your air quality map from your
No.
survey 123?
Not
Just a
yet.
map.
I'm learning how to do that. I went to the Esri conference this whenever it was last summer, and I got all stoked about dashboards, and then I just never had a chance to do it. So that'd be cool.
Well, boy, you should have sat in on my class a couple weeks ago. We did a lesson on dashboards. So now any of my other students can teach you, or you can email me and I can give you some resources.
I'd like
Hint,
that.
hint.
But it's after 5, so why don't we'll wrap this up. I do wanted to say thank you, Boyd, so much. This was really informative, really interesting. And Sophia had a note in here regarding the temperature of the fire. Their friends lost a cabin, and the only thing they found in the rubble was a fully melted cast iron pan. So on that note, we'll end it on how crazy this fire was, and how much impact geospatial science had in predicting it and prioritizing resources and making all those maps every day new maps. So yeah, thanks for shedding some light on that, Boyd. We appreciate your time, and thanks for everyone who attended and to those who stuck around until 5:07. So,
Hey, Elizabeth.
Yeah, with that, thanks a lot. Have a great evening. And
Elizabeth, if I can make a quick plug, the American Red Cross does have a mapping volunteer opportunities for folks, and we did a lot of the use of the products that came from the fires to help support our stuff. So if anyone's interested, redcross.org/volunteer.
awesome, thank you. All right, well, have a great evening, everyone. Enjoy the weather, and students, I will see you again soon.
Thanks, guys. See ya.